let's put on our let's pretend hat. So you've graduated from Iowa State, you've got your degree in cybersecurity engineering or related field. You are now sort of entry-level cybersecurity analyst, IT security specialist, pen tester, whatever your title is for a reasonably large organization. And as part of that task, you review the CVEs that sort of are a constant, endless stream. And we've talked about this, right? That these CVEs, to some extent, come with a score attached, but it sounds like less and less there'll be an official NVD score because they can't really keep up. But it has some technical information of which you may or not have any real expertise in, right? There's a lot of software and a lot of systems out there, and you're not going to truly understand everything that you read in a CVE. It's not really feasible to understand the whole space of computing in such a depth. And you look at this one, and you say, well, okay, CVE 2026, 3/14/31. So March 2026 is one takeaway from this. Sounds kind of bad, published just this week here. We read this in the Linux kernel. Okay, I'm running Linux systems, so I do care about this. Following vulnerability has been resolved. Oh, okay, resolved. I'm good to go. Crypto, ALGF, AEAD, revert to operating out of place. This mercilessly reverts, blah, 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 blah. Gets rid of some complexity associated with what is an in-kernel cryptographic library is what this patch is fixing. Okay, well, so what do we do next? You have a boss. You have a boss's boss. If you're like me, you have a boss's bosses up to about 7 times up the chain here. And you look at this and they ask, well, is there anything important going on in cybersecurity today? Is there anything I need to know about? And you look at this and, well, it's hard to say what one does. NVD hasn't listed it yet or assessed it yet. Again, they've published that they're going to be assessing less and less things themselves and relying more on vendor assessment of the actual score. Kernel.org, so as Linux kernel developers, that organization assigned it a pretty high score, but 7.8. That's high. It's not 9.8. It's high. It's not critical. You probably look at this and you, at first blush, you say, well, seems important. Maybe I just ensure that all of my Linux systems, I did a apt upgrade, apt update, did my kernel updates or my system updates across all of these different systems that I am running. And you're probably safe 999 times out of 1,000 here. Looking a little further, and there's a lot of links associated with it, this vulnerability seemingly motivated or necessitated a one-off website, which is never a good sign. When someone went through the effort of reserving for $13.99 a custom website and domain associated with a vulnerability, maybe that's something that's potentially more important. Still, even reading through this, there is a lot of low-level, I would say, Linux kernel-specific detail associated with this. Of the type that looked through the exploit code, I kind of sort of fuzzily understand it. I don't truly understand it at a level I would think that one would need to know seriously how important this is from a technical perspective. So we could read what the kind of marketing write-up is. Most Linux local privilege escalation exploits or local privilege exploits need a race window or a kernel-specific offset. Do you remember an example of where we needed a race window to do a privilege escalation on Linux? What was that one called? Do you remember? Dirty Cow. Also had its own website. Again, never a good sign for an exploit when it has its own website and own marketing material. This one needs neither of those things, because it turns out the flaw was, I guess, so fundamental that it works on effectively any, in this case, x86 version of Linux running anywhere in the world at the current time. But still, you would think, I would imagine, that, well, I am a IT professional. We keep our systems up to date. I trusted the Ubuntu people that they have their LTS version of it that I have installed. And as part of that, there's going to be a certain guaranteed amount of security fixes. You can keep looking further. You can look at what the actual patch was that actually fixed the thing. But again, you're a security professional. You are not a kernel developer by and large. And it's hard to know, am I vulnerable to this? How big of a deal is this for me? Copy.fail, the website. I don't know the .fail domain, what the intent behind that domain, but I kind of like it. They provide their own, basically, IT professional, cybersecurity professional equivalent of a CVSS score for this vulnerability. Should you patch first? Multi-tenant Linux hosts, our department has a lot of those. CI runners and build farms, we actually have some of those. Standard Linux servers, oh, that's only medium. I guess those are probably okay. This is probably going to be the case for any privilege escalation, vulnerability, and exploit. If you're running a scenario in which you do expect to have lots of unprivileged users sharing a Linux system, I would say that's a pretty high priority. If it's just your standalone, your personal workstation, you're the only user, well, then who really cares all that much? You yourself already have the ability to switch to a super user that you don't need an exploit to do it. It does turn out in this case, if we were to look at the implementation for how one does the exploit, it is deceptively simple, excuse me. It is a little similar to the dirty cow exploit. There it was two threads that were essentially racing to sort of trick the page mechanism into allowing a write that should never have happened. In this case, it's, I guess, simpler in the sense that it is just a single thread, that it's using this particular subsystem that has this privilege already, that never even tried to really prevent against effectively overwriting memory page cache that it was not supposed to be able to. Again, the technical details are a little tricky with regards to how it's actually working, but if you look at the actual exploit here, it works out to be a very simple amount of code here. Basically engage with the kernel crypto subsystem, provide a payload chunk that's going to overwrite part of the page cache for the switch user binary, and then nothing is actually preventing that from happening. You then have some shellcode or whatever exploit you have associated with it, and then boom, you have your reverse shell, remote shell. This is Research Linux 3. This is our department server. Now, it worked as of last night. This is a test of how good our IT folks are at doing these things. They're pretty hardworking people, and they have a lot of systems to manage. And again, everybody who's on these machines is already an authorized user. The question is, what is the threat factor if someone is given more permissions than they should have? Again, I can open up the actual code here. Here's the proof of concept.py. Now, it almost looks obfuscated. That's also something that tends to be the case for these proof of concept exploits. The writers or the publishers, it's a little bit of marketing. Look how small, look how simple this exploit looks like. And so they even say it's only 738 bytes or something like that. That's fine. Less isn't necessarily a goal in terms of having an exploit. It's also then a little obfuscated in terms of what it's actually trying to do. It's trying to just minimize the number of characters and number of lines and things like that. It is effectively the same exact code as what is listed on that copy.fail page. We're going to open up that binary. We're going to write our shell code to it, and because of how the page caching was kind of incorrectly corrupted via having previously accessed that crypto subsystem, we're able to overwrite those necessary bytes. We get access to a root shell. Let's just execute su. Let's just do that as root, and then we have our exploit here. Has this been patched since last night? Who do we think? Do we think it's ETG patched since last night? Hardworking people. This is not necessarily something that, I don't even know, this is Red Hat. I have no idea what version we're running these days. Red Hat 9, I think, on these systems. It sounds like it'd have to be kind of an out-of-band update to fix it. You have to go in, either disable some feature of the system or patch the kernel yourself and rebuild. It's not something that one would necessarily want to have to do, or you'd have to have one specialist in your department who would have that skill set to be able to do that. And as you can see, it does work as intended. Now, what is the actual threat model here? Let's not break any laws. What can we do on this machine now that we have root on it? Well, we can always see who's on the machine. I don't recognize. Oh, Joey Krejci. Oh, he's going to love being mentioned here. Former cybersecurity engineering student, graduate student, graduating soon, is logged into this machine. Oh, let's see. Let's see what he's running. This is probably his research project. Okay, that's just a graphical session. Not interesting, not interesting, not interesting. VNC, so that's all just remote stuff. Nothing. Oh, he's running Vivado. I already feel bad for him. If you're running Vivado, you're not having a good time. If those of you who had to run that in different things. He's on PTS 5. Hello. So hopefully that doesn't mess up his scripting and automation. Let's leave things here for today with our root access on that particular machine. Hopefully he wasn't like capturing the output of something in the shell and using that to drive some automated research. I'll talk to him later, and I will apologize if I slowed him down a day on his research project. But we had to show proof of concept. We have root access. Presumably there's all sorts of things we could do. I don't know the security model for our department machines with regards to accessing home drives and things like that, but it's a big issue, right? My home drive is mapped to that. That presumably has all sorts of student information and grades and things like that. It's probably bad news if someone can access all those things. So that's kind of an interesting aspect of the day-to-day job that you may have to encounter. It is hard to know that, again, for this sort of arbitrary-looking vulnerability, again, you peruse the fire hose of CVEs, you'll see dozens of things like this a month that sound kind of bad. And at first blush, that's really the only takeaway one can have from it. Sounds kind of bad. Hey, we use Linux. Maybe I shouldn't be, or I should be updating or checking or confirming things. At some point, you would have some responsibility to determine, to what extent are our systems vulnerable. And then you have to go to the remediation side of things. Well, and there's a step in between that as well, right? So we have to do that sort of logging activity to know, has anyone on our current systems, have they actually exploited this bug already? And depending on what kind of logging infrastructure you have set up, and we talked a little bit about that in that topic, you may or may not be able to determine, has someone actually set these things up? I guess for that particular system, someone could tell, who is actually logged into this system and what kind of access do they have, and what commands have they been running. You may be able to do some kind of post hoc determination. You can log all super user actions to determine, have we actively been exploited by this, or is it just sort of a theoretical concern for us? So there's that remediation step then of how do we actually go through and patch it. I'm tempted to fix it myself. But what are the odds I break down the whole system and then I actually get into a little bit of trouble? Probably that second level of responsible disclosures next is, okay, admins, take a look at this website, get this thing fixed as soon as possible. The other thing this is a pretty good demonstration of is that thought of Patch Tuesday leading to Exploit Wednesday. That was more of a Microsoft thought. And here the chicken and egg isn't quite that clear to me. Did the patch get determined after a responsible disclosure, or did they happen awfully close to each other? Because the way the system is supposed to work is this shouldn't actually be an issue. By the time you see about a really crazy CVE that can cause you some real grief, it should only have been made public once the general assumption is that your systems have been patched and you're no longer currently vulnerable to it. So your response to reading a CVE like this generally should be, phew, I'm glad I have followed good practices and have kept up to date with my software patches and things like that. So there is a patch. And again, I would say that I myself don't necessarily have the skill set to look at this patch and say, oh, there's a really clear exploit that this was fixing. Because if you look at the notes for it, it's not mentioning that this was a patch to fix a known vulnerability or that this was a really bad exploit that this was being able to prevent. It looks like more of just cleaning up some code that probably wasn't written very well in the kernel. So that chicken and egg of, did the patch get released in March, which allowed people to really determine that there was an interesting exploit available on systems, or did the patch come after there was some responsible disclosure? If you look further at the copy.fail website and the organization that used a specific tool to do that kind of looking through the kernel, they do mention there's a whole lot of these other things out there that they have not released publicly yet. So there's some level of responsible disclosure going on here, but maybe a little bit of an arms race as well, because when there's a bug of vulnerability of this level in the Linux kernel, the goal is to fix it right away, but these organizations are relatively slow. Kernel might get patched. Kernel patches have to then get upstreamed into the various distributions. That requires testing as well. This case, the patch I don't think disables any actual expected functionality, but for some of these other vulnerabilities, it may be to actually apply this patch, you may have some other code that may not work the way you expect it to. And so there's a level of testing required. Questions about copy.fail. This is kind of just a one-off topic, and it was fun enough I thought we'd bring it up. It's a good experience to look through these things. Again, pretty low-level kernel internals to actually understand where the page caching is happening, why this particular library has that level of access was a design decision that maybe was a good one, maybe is not. I can't really say for certain, but it's worth a separate slow walk through it and see, here's what these kind of exploits do tend to look like in practice, because then the actual code that does the bad thing is pretty straightforward here, which is overwrite this executable, because we have the ability to do so with a bunch of shell code to run and to change user to root on any particular system. The other, again, interesting impact is a lot of these other CVEs that have potential things like privilege escalation, they tend to be a lot more windowed in terms of what type of systems that they impact. It tends to be, if you're between this version and this version kernel, and if you're on this 3-month window where the bug was introduced to where it was fixed, or if you're on this particular distribution or this particular underlying architecture, then you're vulnerable. But then large percentage of people are not then vulnerable kind of by definition there. This one's interesting because it seems like by default, every Linux system in the world that doesn't have that particular kernel patch is currently vulnerable. So go out there and exploit systems and have fun with that after the fact. Officially, that is not my advice. On systems that you own and have full control over. I wanted to kind of just finish up this topic of malware. We were really focusing primarily on, what are the goals of the malware in terms of categorizing the goals. What is the mal stuff? What is the malicious stuff that the software could be doing? We talked about sort of the triggering of it as another way to concern yourself with malware. These are kind of orthogonal concerns, right? That the bad behavior is one dimension of it. How it gets triggered is another one. So you could have a logic trigger for a certain type of malicious activity or a time-based trigger for another type of malicious activity. And in terms of that malicious behavior, we have already kind of played around a little bit with, but I just want to talk a little bit more about so-called these attack agents, these botnets or just zombies or just drones. The goal of this attack is to take over computing resources for the purpose of doing something else. Oftentimes, at least for historical reasons, that doing something else is to do distributed denial of service, to take down some other computing or networking infrastructure out there. If it's just a few machines, that doesn't seem like it's worthwhile to have all this hierarchy and complexity. The idea is that these botnets can grow to the size of tens to hundreds of thousands of nodes that are taking over, and that becomes a lot of computing power when taken together. That becomes a lot of bandwidth when taken together, and there's been all sorts of stories, and we talk about that when we talk about Internet of Things devices. It's related to this. The IoT devices are a nice target for botnets because there's a lot of them, and the other reasons that IoT devices are potentially not very secure. But this is just in terms of what is the actual malware doing. It's kind of interesting to look into botnet code and what is it actually doing in practice. Again, the general design philosophy is there's a separate kind of recruitment stage and then an actual activation stage. So they are lying in wait. They are bots waiting to be activated. They are drones or zombies waiting to be turned on and actually sent to do anything. So there's a separate stage there's the infection stage. There still has to be some vulnerability, giving you access to be able to run some malicious code on those individual devices. But as part of that, by default, they're not necessarily doing anything to start with. They're sitting there, and amongst what other legitimate tasks they're supposed to be executing, they are waiting for instructions. That is the so-called command and control side of things. They are requesting next bunch of work. Give me my next task. So they're just sitting effectively lying in wait, doing whatever other legitimate tasks the computing resources are supposed to be doing, but then periodically checking in with command and control and saying, what is my next task? That is the main thing that differentiates a botnet from just a widely spreading worm. A worm's goal is to look out, actively seek out, and infect things and kind of just spread. Botnet also looks to seek out other computing resources and spread, but it's doing so via this sort of hierarchical command and control structure here. Someone is in charge. Someone is saying, I'm configuring this other computing resource to be the one who's actually just passing along instructions. Recruit more bots. Look through this IP range and look for potential vulnerable machines now. Now I have this list of all the machines that I personally have some remote access, some remote control for. Now at some point in the future, now launch some coordinated distributed attack. And again, there's other things you can do with a botnet, but the distributed denial of service is the most sort of obvious thing. I have 25,000 machines with a lot of potential network bandwidth attached to them. Let's go try to take down this website that's saying mean things about me. The difference then also is that there has to be some sort of person in control. And the worm itself, when it gets launched, then potentially you lose control over it. There's this code, its goal is to kind of self-replicate. There's nothing telling it to stop that action of self-replicating. The systems themselves have to get patched for that worm to stop propagating. Here, there is some top-level control that if you could take over that resource, you could then take over the entire bot. And you hear all sorts of stories of this bot army got taken over by this other bot army, and they're trying to sort of exploit and re-exploit each other. But then the other aspect of it is, how does that communication happen? This could be any sort of just network connection. So it's nothing magical from a networking perspective, but that is also sort of the weakness in a botnet design, is that if I can take over that command and control activity, well, then I can stop the botnet right away. If I could just prevent this particular type of traffic from happening, then there's going to be no further commands to the botnet. So the actual novelty in a botnet design happens to tend to be in the design of those individual arrows, what protocols, what architecture I use to actually reliably send those commands. And it's been just kind of a fun sort of, try anything and see what actually scales, what actually works. Pretty much anything that has an automated way of posting a message has been historically used for botnet control. Historically, it was all IRC, Internet Relay Chat. But how many of you actually know what IRC is? Okay, it's a precursor to Discord in some ways. I don't know. Just a protocol and a dedicated port number that we use to just kind of send messages and sort of the original live chat that was kind of internet scale. It's relatively easy to detect that particular type of traffic, so that is one fix. If I'm worried about botnet spreading, I just turn off that port on all my potential systems, and that will prevent future updates. So as I said, any service that has some programmatic way of updating state, of posting a message, will also work. There's all sorts of examples where people have just used email to control botnets. Gmail drafts as command and control. So you can access Gmail drafts using the Gmail API, and if you just have an account, these individual bots would look to there to see what messages have been posted and updated in that draft. That was considered pretty good tradecraft back in, 15 years ago, and now it's understood that people can detect that kind of traffic as well. And to take over the botnet, you would just have to take over that particular Gmail account. But email could be used for controlling social media messages. There's been all sorts of examples of botnets that are using a separate subreddit that looks like it's just posting garbage nonstop, or X Twitter messages to be able to post those things. And that's been a very common example historically of how one could control a botnet. The solution for that has been more just kind of limits in terms of how much programmatic activity you can have on those platforms. So it is harder today than it was 5 years ago to have a sort of a fire hose stream of messages posted to most social media networks. There's also been all sorts of examples where DNS entries have been used to update commands to botnets. And again, when you want to think about the command, it's usually a relatively straightforward thing. We played around a little bit with the Mirai botnet when we were doing our earlier IoT-based lab, but it didn't probably feel very real because it was like one computer and then one target, so it didn't feel very net in terms of the botnet here, a single bot, single target here. But we did have a command and control server, and there it was just plain socket connection saying, attack this website. Send some traffic at least to this particular IP address, excuse me. That's still the nature of what the commands would look like even in a modern botnet. It is target, and here's the particular attack needed to launch against the target. When we've looked at malware, what have we noticed though, right? We've looked at the source code for various malware examples. A big chunk of it is actually just crypto code, right? Because the goal is to try to prevent someone from easily determining what kind of behavior is being sent over the wire. And so you'll have a lot of just well-established cryptographic code in there to say, I'm going to send this message, but it's going to be hard for someone who doesn't already know the private key to figure out what those messages were intended to be. So sometimes a big part of breaking down and kind of disabling botnets is either infiltrating the command and control infrastructure. If you can determine which API was used for posting messages, and if you can take over that resource, then you would have control over the botnet, or breaking the actual crypto associated with it as well, the cryptographic algorithms associated with it as well. If I can determine what key they're using to encrypt these messages, then I can decrypt these messages and determine what the botnet is doing next. I don't think it's that clear based on the way I described it here, but the idea behind it is it's not just a single command and control server, and as soon as I unplug that, the botnet is done. The idea is that is a resource that is itself moving fairly frequently, on the order of days, not on the order of hours or minutes necessarily, but it's moving every so often. And then there's some predetermined algorithm that tells the bots themselves that you are connected to a certain command and control interface or a server, and that's going to change now. Now we're all going to go to this next resource. So one of the examples you still do see is this idea of DNS fast fluxing. I don't know if I have the example here. Just a description from Cloudflare of what DNS fast flux is. It's just associating a whole bunch of IP addresses with a domain name. And by updating those entries, you can tell the botnet, hey, keep connecting to this domain, but where that domain is actually physically located in terms of the IP address is going to change and can change fairly rapidly. Now, you may say, okay, I have my domain name that is the command and control for that botnet. Why can't someone just take down that domain name? Depends on the domain name. If it's something.com, it was registered using an established domain name registrar in the US, presumably you could get some legal or other order to get that domain taken down very quickly. But just for instance, I know nothing about the .fail domain. Who runs the .fail domain? Who did one register the .fail domain with? Who actually has control over it? Will they listen to a subpoena requesting that a particular entry be deleted? I have no idea, and that's just the one example that comes to mind. There's a lot of domains out there, a lot of different domain registrars. You can actually then use DNS, even though one would imagine, oh, we should just prevent that domain from being live anymore. That's not always necessarily a very quick fix. It may require a protracted legal process. When we talked about Stuxnet very briefly on Tuesday and talked about how there was also a command and control associated with that. It was lying in wait, not as a botnet to carry out distributed denial of service, but lying in wait to be given the command to say, hey, go now do the PLC code where it was increasing the frequency and decreasing the frequency to destroy the attached centrifuges. It was waiting for some command to do that, and that command was via some I forget the exact domain it was using, but it was something like watcheurofutball.com or something like that, which I guess if you're an IT administrator in Iran and you see some web traffic to watcheurofutball.com happening on these machines, you think, well, it's pretty boring working in the uranium enrichment facility all day, and it's okay to watch the Premier League every so often. So that was just an example where it was just HTTP traffic, but it was kind of hidden via a DNS mechanism that, at least in this case, looked kind of anodyne. But in general, even if one knows that this DNS entry is something that should be potentially taken down, it's not always a straightforward thing to say this domain should no longer exist. It's being used to control malicious actors. That's not necessarily something that you can turn a switch and instantly get that turned off. Today is unfortunate because we're kind of jumping a lot of different places. So from copy.fail to wireless networking to controlling botnets. Let me just introduce this topic today, and then that'll be your justification to come back on Tuesday. And my justification is actually a little weak for this topic, other than it's an expected topic that one should know if you understand wireless security. That's important for cybersecurity professionals. The challenge with this topic is it is certainly sufficiently large that it does justify its own course or potentially multiple courses, because there's multiple different aspects one could cover this topic from. Wireless networking itself is a topic that is not strictly a computer engineering topic or a computer science topic. It very quickly becomes an electrical engineering topic and a signal processing topic, as does wired networking, but the wireless aspect is more interesting, all the RF things that are happening there. And so for that reason, the security aspects of wireless networking also sometimes start to broach into EE land as well. I think our purpose, given a lecture and a quarter on this particular topic, is just to get some high-level exposure to the idea. It is a massive topic. We have an entire undergraduate course dedicated to it. Highly recommend you take it. It's a very good course. If you get this introduction and you really seem to like it, that would be the next course of action. Would be to go register for that course. It may expect you to have some sort of more systems background. I'd have to check the prerequisite for that. But in terms of security background, you have more than enough after having gotten through 2300 and 231. You've already taken it, or you're in it right now? Yeah, excellent. So good. Thanks for that. It's Professor Salim, right, who teaches that course. So it's supposed to be a very good course. And then there's the graduate level version of it as well, if you have to wait till you're maybe in graduate school to take it. It's a pretty big topic area. And again, even one course probably doesn't really cover all of it. There's a focus more on Wi-Fi and related wireless networking standards. That is just one branch of the very big world of wireless communication that is out there. We'll try to focus, certainly on Tuesday, on just some more practical and historical things that have happened with regards to wireless security, and just get a little flavor. That's all it is, because we're really done with the course otherwise, and that's a good thing, right? The semester is ending. So this is all kind of bonus content. When we do have our last macro quiz next week, I won't ask any wireless security questions on it. So come on Tuesday, but you don't have to worry about, do I have something sufficiently understood and memorized for the purposes of a final assessment, and there's no worry about that. Question, sure. The videos? Lecture notes. Sure. Yeah. Have you not been watching? Have you not been subscribed to my YouTube channel? I can't even say tens of subscribers. I have ones of subscribers right now, and I need to get those numbers up because the monetization is not really working out right now.